Hello everybody, today we are going to talk about real design of cathodic protection system. Cathodic protection principle is to minimize electric potential difference between anode and cathode by using external source of DC current to protect cathodic metal. There is two types of cathodic protection system. The first one is the galvanic cathodic protection system and the second one is impulsed current cathodic protection system. The galvanic cathodic protection system known as superficial cathodic protection system and external anode protects metal from corrosion and certifies itself acting as anode during corrosion process.
Firstly, we designed a galvanic cathodic protection system for underground steel storage tank of offshore platform. By calculated the total current demand, then we calculate the anode weight by from the anode capacity, then we calculate the soil resistivity. We calculated the current of each anode from the standard reduction potential of zinc because we use zinc as anode. We calculate the anode number by divided the initial current demand over the current of each anode. All these steps we calculated to get the areas that will be protected by each anode. So we will divide the submerged area over the total number of anodes.
Power supply is provided to metal surface for creating large potential difference between allowing more current to flow from cathodic protection anode to metal being protected.
The second step, we design inverse cathodic protection system for main gas pipelines. Firstly, we calculated the pipeline outside surface area from converting the diameter from the feet to a meter. Then we calculate the current demand depending on the coating efficiency. The anode selected was a high quality silicon chromium cast iron with a weight of 6 pounds. That helped us to get the anode number requirement for design. The anode number calculated was 0.5 is less than 1, so 1 will be enough, but we to be sure that we will not be corroded the cathode part or pipelines, so we bought 3 anodes to be in safe side. Then we calculate the anode resistant ground bead depending on the average soil resistivity. The selection anode bead area for placement was 100 feet with resistance 0.0159 ohm. Then we calculated the anode grounded resistance for bead for 500 feet header. It was 0.0795 ohm. Finally, we calculated resistance from structure to electrolyte depending on resistance per unit area to calculate the total circuit resistance. All these steps was calculated to get the rectifier voltage. That calculated depending on the current demand multiplied to total circuit resistance, multiply 150%.
In galvanic cathodic protection system, no requirement of external power source. Anode can be easily installed, and in ICCP system protects the large area more effective, easy to monitor and control. In cost estimation, we have to calculate total capital investment, fixed capital investment, and working cost. There are 9 factors in direct cost and 3 in indirect cost. Working cost equal 15% of FCI. Working capital is the additional investment needed over and above the fixed capital to start the plant up and operate it to the point when income is earned.
The number of anodes calculated for galvanic cathodic protection was 2,591 with mass of 922 kilogram. The cost estimation for each kilogram was $1.1. So the total cost estimation for all the anodes was $2,651,000. Then we calculated the fixed cost investment by the sum of the direct cost and indirect cost. Then we calculate the working cost by multiplied the FCI multiplied to 0.15. After that, we calculate the total cost investment.
The total investment of galvanic protection system is 10,500,000 for 35 years using 2,591 anode with constant maintenance. Also, however, if we buy a new tank of some capacity, will cost around $3,000.
The total purchase for the emergency cathodic protection system was the rectifier cost estimation plus the 3 operating anodes that we used. So it was $865. And the total cost investment of this system was $300,424. That came from the fixed cost investment plus the working cost.
The ICCP system just requires 3 anodes to protect the whole pipeline. So this method is preferred over the other coating process to protect the pipeline from corrosion.
Business plan made about 3 categories. The first thing is vision, is to lead the corrosion protection industry by providing the best concentration. And the second thing is mission, is to enable industries and chips to stay stable and healthy for a longer period. And the last thing is values, which consist of innovation and sustainability. Utilization and importance. Its global corrosion protection market size is used 22.8 billion in 2019, and it's projected to increase 8.3% by 2027. And its high utilization is in marine area, and our product is best for our protection of corrosion in ships and in marine pipelines.
In marketing plan, we have to formation of website and other social media account. Then we have to add ads on Google, because any search related to corrosion will be shown in an ad link. Then we sending the proposal to the concerned industry. Then the article writing. The article related to the issue of corrosion and their technical solution will be published on the Twitter, and link will be given on website to make people know more about the issue.
In conclusion, one of the best way to protect metal from corrosion in industries at areas like pipeline plutonium is ICCP, emergency cathodic protection, uses external power supply, allowing more current to flow from anode metal to metal being protected. The ICCP system costs depending upon system size. Galvanic protection system have greater number anodes and require more arrangements for installation and maintenance, so it is cost more as compared to emergency cathodic protection.